This is how to filter your data. So there's two different filters we're going to want to use. One is going to be a band pass filter, which is going to pass the data in the middle range, the middle frequency range, and will not pass the very low and very high frequency data. We don't want the really low data because that's just a slow drift, which is usually caused by electrodes, which we don't want, and we don't want to pass the really high data because that's gonna not be neural data. It'll be probably muscle or other kinds of noise. And the second filter we're going to want to do is the 60 hertz notch filter, which removes the 60 hertz line noise. Okay, so in order to do this, you're going to click Tools, Filter the Data, Basic FIR Filter. So for the first one, we're going to do a passband filter, and we want the lower edge to be 0.1 and the upper edge to be 100. And these numbers can vary. There's different arguments for why you would do either. If you do if you filter out too much of the data, it'll really change the shape of your waveform, and if you do not enough, then you'll have a lot of extra noise left over. So it's a balancing act, and yeah, there's different reasons you want to do either. So I'm just going to go with this for now. So we enter those numbers in and then just click OK. And then we get this plot, which is called the frequency response plot, but we don't really need to look at that right now. And then it takes a while to run, and you can check the progress here. And when it gets to 100%, this box will pop up where you can rename your file if you want. So I might call it, filtered. And it'll save as a new data set in EEG-Lab. Click OK, and that's done. So now we're going to do the 60 hertz notch filter to filter out the 60 hertz line noise. And again, Tools, Filter the Data, Basic FIR Filter, except this time we're going to use a notch filter instead of a passband, and a notch filter will get rid of what's between these two values instead of only keeping what's between the two values. So we want to get rid of the 60 hertz line noise, so we're going to go from 59 to 61 hertz and do the notch filter, click OK. Again, we get this diagram, which we don't really need to look at, and the data is filtering right now, which will take a minute. And that one went pretty fast, so now that it's done, we can rename the dataset if we want, or we can just keep the same name. Now if we kind of want to see what those filters did, we can look at the channel spectra. So go plot channel spectra and maps, and then we want to plot to, we'll say 120 so that we can see the filters that we did. Click OK. It'll take a while. And now that it's done, we can see, so this is the Fourier transform of our data. And so this is the power on the y-axis and the frequencies on the x-axis, and each of these lines is a different channel. And so you can see there's the peak at the 10 hertz, which is good. That's a lot of the neural data center around 10 hertz, so that's good. And we can see right around 60, there's a big dip, which is good because our filter is supposed to do that. And then right at 100, there's also a big drop off in the power, which is also good.